Hi, my name is Patrick. Welcome to video 3 in the series analyzing the Tiempo and Colombia and Vivo Chrome extension malware. In the first video, we went over the JavaScript that's actually in the extension file. This was reviewed by Google and given the OK to put on the web store. We deobfuscated it and created this HTML file to get the image data. And if you're wondering, yes, you can in fact put this right into Burp's decoder and get it out. But we did it the other way. And we got this payload right here. And this is where we start today. So this stage 1 payload contains a string, and the rest of the file is not obfuscated at all. So we know what it does. So it gets a payload, it's able to run it, and here's an initialization method. So it waits for a while before downloading the payload. We can see it creates an XML HTTP request. It expects a JSON response, and then it gets it using a base64 decoded URL right here, and then it runs the response. So we're going to copy the base64 value into Burp's decoder and paste it in. And here we have a URL. So let's visit this. So here's the next stage in this malware. Let's copy this into a file in Sublime, and I'm going to get rid of these double quotes. We're going to save this as stage2.js. Then we're going to copy it, and we're going to go into the online JavaScript beautifier, and we're going to have this beautified. So we're going to copy this back into a file in Sublime, and we're going to save this as stage2-beaut.js. So now we can analyze this a bit. The first line here declares a variable. It's a long string, and at the end here, it's actually splitting the string into an array, and it's splitting it based on these semicolons. So before we go further, let's actually compare the indices of this string with the actual values that are there. So I'm actually going to split this up into 2 lines, and then I'm going to go through and number these based on their index, and then I'll be back when this is done. Alright, so I've marked each index to the string that it results in. So it goes from 0 to 22. And those correspond to the values throughout the rest of the file. So I'm going to go through and replace each of these values with the corresponding string. And in most cases, these will be function calls. So here we see XML HTTP request, and this is string number 2. So this is actually the function open. So I'm going to show you this, dot open. And this is the string right here. And I'm going to go through and replace all these. So I'll be right back. Okay, so I've gone through and replaced all these values with their corresponding array element. So we can see a new HTTP request, and it's opening using the method, and it's base64 encoded. So let's go to burp and decode it. It's actually get, the function get, the method get. And then this is also base64 encoded. Let's paste that in there, and it corresponds to this link right here. So they're using negated 0 right here, so I'm going to switch that out with true. So we can see they're making an HTTP request. They're using an authorization header. They're going to base64 encode this. This is the username and password for that website. And then they set the onReadyState change function. So as soon as this request loads, it's going to check the ready state and it's going to check the status of the response. And from there, it's going to parse the response text and then do this function, this for loop over it, modifying it. And then it's going to create a new function from the value that it gets here. So if we were to try to put this in a HTML window, we will find that it doesn't work. So I'm going to do that now. We'll save this as stage2.html. And let's open this in Chrome. Let's look at the console. And we'll see that there's a syntax error. Even though this JavaScript presumably ran when we got it from this link here, it doesn't now that we've beautified it, or at least it doesn't in a browser while we beautified it. So let's try the unbeautified version. So let's copy this, paste it in, save. Let's reload this page. So it still has a syntax error. So when I first was analyzing this file, I successfully modified it in order to print out whatever it got from the network. I'm going to paste that right here so you can see it. So there are a few differences. They start around here. So I'm not sure why this happened, but maybe the malware author changed the payload that they were hosting on that site. I'm not sure, but I've modified this one to log the function output. So what it was trying to execute here with the new window function, it's just going to log that to the console. So I'm going to delete this part we just made ourselves. I'm going to save this, and then we'll be running this old code that worked. So I'm going to reload, and we'll see it failed to load, and because the authorization header was not allowed. So what we're going to do about this is we're going to man the middle, our connection. So we're going to go over to proxy. We're going to look at the HTTP. Actually, we're going to go turn the proxy on, at least turn the proxy settings on. We're going to request this again, so we get it into our log here. We're going to add, we'll actually go over here, add this to our scope, and stop sending out of scope items there. And now we can see it's doing an options request, and now it's saying it's not allowed. So what we're going to do about that is we're going to go to options, intercept server requests, and do that when the target is in scope. And then we're going to turn intercept on. Now when we request this again, Burp is going to pop up and say, hey, we've got a request. So I'm going to forward this options request. And then we're going to modify the response to that. So we're going to delete this method not allowed stuff. And then we're going to add, or rather, we're just going to delete these allow headers and replace that with a star. So that star means that all headers are allowed. And then we're going to forward this. And now we're going to see the actual GET request to that URL that we saw. So we're going to forward this. And from here we can turn intercept off and just wait for it to respond. And here's the response here. So this is a jumble of Unicode and stuff. Basically it's encoded somehow. But what we did in our script here, we modified it to log the output of that decoding. So I'm going to select this and copy it into a file. This is very long, so it's going to take a while, so I'll be right back when I'm done. Alright, so I'm going to copy this, make a new file in Sublime, paste it in, save it. This is going to be stage3.js. Hit save. And now let's copy this into a new file. Put this through the JavaScript beautifier. Hit beautify. And then we can copy this all out and into this new file here. We're going to save this as stage3 beaut, beaut.js, and we'll be able to see our syntax highlighting here. So the first thing that we see, because it brought us to the end of the file, is these redirections. So when the Ars Technica article was talking about how it's impossible to manually uninstall, they were talking about this redirection here. So when you try to go to Chrome extensions to uninstall this extension, it'll actually redirect you to this URL, and that URL does not allow you to uninstall the extension from there. That's only for apps. And if we scroll up, we can see that happening right here. So if we take a look at these other redirections, they're mostly for antivirus and other kinds of things that users might search for if they need to clean up this infection. So when they're redirected to their new tab page, it effectively renders Chrome useless for downloading antivirus and things like that. So any infected people reading this Ars Technica article that are trying to download Malwarebytes to uninstall this, they're going to have a hard time doing that in Chrome. They'll need to open up Internet Explorer or Edge or Firefox if they have that installed, because in Chrome they'll just be redirected to a new tab page. Here we can see some functions to do with watching videos. One of the things that Ars Technica said that this malware did was fraud, so click fraud and video fraud. So we see it here, rating comments and subscribing to channels and rating videos. And here's the authentication stuff. Here in this utils function we see LZW decode, and if you look carefully you'll recognize this code from the stage 2, so this right here. And here we can see that this is what's handling the commands from the command and control server. So it's deciding whether to watch a YouTube video or to rate a comment or subscribe or rate the video. And it's logging the successful commands that are being run. Here is the get actions function. It runs the get action HTTP request, so it's requesting from the server this URL get/actions. So let's actually go to our stage 2 HTML file, and we're gonna try and switch out the init code with actions. And so we're gonna encode this as base 64. And now we're going to copy this into this file and replace the original init code base64 encoded URL and replace it with that. And now one more thing we need to do is go back into burp proxy and turn intercept on, because we'll need to do the HTTP header stuff. Forward a bunch of these things. And now when we reload our stage 2 HTML file, instead of printing out the init code, it's going to print our actions. So we need to go to burp, forward these requests, forward this one. This is an options request. And we'll see some other Microsoft ones because I'm running Windows and it's trying to update. And here's the response from the server about the options. We're going to modify this. So we're going to delete this method not allowed, and we're going to add, or rather change this to allow all headers, and then forward this request. And here is our final request to /get/actions. We're going to forward that. And then we can turn intercept off now. And we can wait in here. And we'll see that we get another encoded JSON response. So let's take a look at what our script decoded. And we can see here that it's telling, or it's trying to command our what would be our listening Chrome extension to rate some videos as well as subscribe to some channels. So I'm going to copy this into a file. We won't need to analyze this. We're just keeping this for posterity. Create a new file, paste it in, save as actions.json. And that's saved. Here we see a link to this website, socialextensions.top. I'm thinking this is the publisher of the malware, possibly. They're definitely doing the listening to the results of the command actions. So they're controlling what YouTube videos should be rated, what comments should be thumbs up, what channels should be subscribed to. When we scroll up a little, we find some more base64 decoded values, or encoded values. They look like, well, they are the developer URLs. So the malware devs were using these URLs on their local server to test this Chrome extension. So this is localhost. And this is also a local address, 127.0.0.1. And this is the final thing that we'll look at in here. It appears that they're doing some search engine manipulation. So they're talking about Google, and they're talking about organic and referral. These are terms that search engine optimization stuff uses. I'm not an expert, but it definitely appears that they're using search results or abusing them. If we do a quick search, we can also find other search engines, along with the indications in the URL that they're searching for a query. So with Google Images, it's Q, Google stuff is Q. For an euro, I've never heard of that, but apparently they use search word. And this is more search engine manipulation code. So I hope you've enjoyed the series. I appreciate you watching all the way through. My name is Patrick, and thanks.